inequalities you did in Algebra 2 and probably a little bit in Algebra 1. The only difference is we're not just looking at lines, we're looking at linear and nonlinear. So let's say I ask you to graph the solution to this system. The solution to a system is anything that makes both of them true. So we have to graph each of these individually. If we just take this and get y by itself, it tells me y is less than or equal to, if I subtract my x, negative x plus 2. So we should all know how to graph that. This is a line. Your y-intercept is let me go get Mrs. Keller to come in here for a second. What's your y-intercept? 2. So we hit the y-axis at 2. What's your slope? Negative 1. So that means like down 1 over 1. Or you could go up 1 and backwards 1. When we graph this, we have to decide if it's solid or dashed. Do you guys remember how we know? If there's an equal to, it will be a solid line. If there's not an equal to, it's a dashed line. So, do you guys need rulers? Yeah, it'll be just fine. Okay, so there's my line, solid because it's equal to. Now, because of the inequality, we have to shade our line. When we look at this, there's 2 ways to decide how to shade. If you catch it, less than tells me the y is less than this, that means it's just below the line. So if you understand that, you can just say, okay, I'm shading below. This isn't my final answer yet, so I'd recommend like lightly shading that in at the moment. A lot of times, I think Mrs. Keller had you guys do test points. So you had to pick a point that wasn't on the line. 0, 0 is a popular one if it's not on the line. And you plug it in. If I put in 0, 0, I get 0 is less than or equal to 2. Is 0 less than 2? Yes. So 0, 0 is below the line, and that told me to shade below. So you can either, if you can catch it from your inequality and know how to shade, you can use that. If you don't understand that, then do a test point. Now we have to graph the second one. So if I solve for my y, subtract over the 2x. So y is greater than negative 2x plus 4. So my y-intercept is 4. We touch the y-axis at 4. Slope negative 2. So down 2 over 1. Or you could go up 2 and left 1. I have to put a lot of points because I'm not good at drawing straight lines up here. Solid or dashed? Solid because it has an equal to. Okay, and then it's greater than. So do you know where you would shade? Greater than is above. If you don't understand that part, you could do your test point. 0, 0 isn't on the line. If we put that in, we get 0 is greater than or equal to 4. And that is false, so we can't shade 0, 0. We shade the other side. Now our actual answer is the overlap of our shading. So that's this region in between the 2 lines. So make sure I can tell what your actual solution is, so you should darken that in. Some people go back and erase some of their other marks or use a highlighter or color pencil, whatever, as long as I can tell where the solution is. That means any ordered pair in that black region makes both of the original inequalities true. What questions do you have for me there? Let's do another. So first step, we need to get our y by itself. If I subtract over my x, I get negative 2y is less than negative x plus 6. If I divide by negative 2, what happens to my inequality? Flips. Anytime you multiply or divide by a negative, it flips. So it's greater than, if you divide each of those by negative 2, you get a positive 1/2 x minus 3. So when graphing this one, the y-intercept is negative 3, with the y-axis at negative 3. The slope 1/2, so up 1 over 2. Solid or dashed line? Dashed, because there's no equal to. And then you have to figure out where to shade. So you could either look at it and say, okay, greater than if y's are above it. Or if you put in a point like 0, 0, you get 0 is greater than negative 3, which is true. So we need to shade where 0, 0 is. So just lightly shading above this line. Second one, if I subtract over my 2x, divide by negative 4, dividing by negative flips the inequality. Negative 2 over negative 4 is 1/2. So that line has a y-intercept of 0. So 1/2. Solid or dash? Less than would be below, or if you were doing a test point, you can't do 0, 0 this time because it's on the line, but you could maybe do like 0, negative 1. And if you put that in, you get negative 1 is less than 0, which is true. So you're shading below. So my actual answer is the overlap, which in this case is this region between the two parallel lines. Every ordered pair in that black part makes both inequalities true. Any questions on that? Look at this one. X squared plus y squared is greater than 9. X squared plus y squared, that's not a line. Does anyone know what that is? If it's y equals x squared, that's a parabola. This time both of them are squared. So if we don't know, we could, what? What do you do if you don't know how to graph something? Make a t-chart. Okay, let's try that if we don't remember how to graph it. So if I put in a 0 for my x, think of it as an equal to for a moment. You get y squared equals 9. If you square root, what do you have to put with that? Plus and minus. And the square root of 9 is 3. So we get two solutions. So we have 0, 3, and 0, negative 3. Okay, what if I put in 3 for my x? Then I would have 9 plus y squared equals 9. So y squared is 0, so what's y? What's the square root of 0? so we get 3, 0. What if x were negative 3? Negative 3 squared is still 9. So we again get y to be 0. What is this? It's a circle. Solid or dash when I graph that? There's no equal to, so it'd be dash.
Is it when the, if it's to a 0 power, it's 1?
Yes.
Yeah,
Yes, when the exponent is 0. Okay, shading. So if we don't know, let's try test point. If we put in 0, 0, we get 0 is greater than 9. That is false. So we can't shade 0, 0. That means we are shading everything outside this circle. So all the stuff out there is shaded. All right, you guys graph the second one. That one's linear, so you should be able to draw that graph and do that shading. So to graph that line, we need y equals mx plus b form. So if you subtract over your x, y-intercept of 3, slope of -1, so down to the 1, solid or dashed line. You could recognize less than shades below, or you do your test point. So you get 0 is less than or equal to 3, which is true. So 0, 0 works, so we're shading below. So the overlap is everything below this line, but outside the circle. So we're getting this region here. Is that one okay? We'll do at least 2 more. I have others on here. We'll do whatever we need to. Do you guys remember what y equals x squared minus 4 is? It's a parabola. What does the minus 4 do to your parabola? Moves it down 4. So you could recognize it from that. You could also plug in some points. So if x is 0, you get -4. If x is 1, you get -3. If x is 2, you get 0. -1, -3, -2, 0. If it wasn't equal to, so it's a dashed line. Trying to decide where to shade, if you put in 0, 0, you get 0 is greater than -4, which is true. So 0, 0 works. So what we're doing is shading inside the parabola here. Then the second one is a line, y-intercept of -2, slope 1, equal to would be a solid. Says y is less than, so that's below, or if you do your test point of 0, 0, you get 0 is less than or equal to -2, which is false. So you can't shade 0, 0, we're shading the other side. So our overlap is the part in the parabola, but underneath the line. Is that one okay? All of these have been a system with only 2 equations, but you can certainly have more than 2. You can have as many as I give you. So if I look at this one, I actually have 4 different equations we're looking for the overlap of. X is greater than or equal to 0. If you have x equals a number, what kind of line is that? X equals is vertical. Y equals a number is horizontal. So this is a vertical line at 0. So it's just the y-axis. Greater than tells me we are looking at everything to the right. That's the first one. Second one, y is greater than 0. So y equals 0 is the x-axis. No equal to, so dashed line. Greater than, so it's above. So far, what's my overlap? Yeah, just that first quadrant. Okay, if I do the next one, I get y is greater than or equal to negative x plus 2. So y-intercept of 2, slope negative 1. Will be a solid line. Greater than is above the line, or you can do your test point. And 0 is not bigger than 2, so we're just going here. So all it did was took out that little corner of the first quadrant. Last one, negative y is greater than negative 2x plus 4. Divide by negative 1. When you divide by a negative, it flips your inequality. Y-intercept is negative 4. Slope is 2, so up 2 over 1. No equal to, so dashed line. And if you recognize it, less than is below, or if you do your test point, you get 0 is less than negative 4, which is false. So 0, 0 doesn't work, so we are below this line. So our overlap is this part of the first quadrant. So the hardest part when there's multiple equations or more than 2 equations is usually just keeping your work neat enough that you can tell what your overlap is at the end. Why don't you guys try the last one? How do you graph this first thing? Negative 4 is less than x is less than or equal to 0. X equals a number is what kind of line? Vertical. So it's just saying you have 2 vertical lines at negative 4 and 0. Since there's no equal to, those are both dashed lines. And it says x is between them, so you're just shading in between those 2. Okay, second one, y-intercept is 2, slope negative 1, no equal to, so dashed line. Y is greater than, so we're shading above. Last one, y-intercept is 10, slope is negative 2. So down 2 over 1. no equal to, so again, dash line. Less than is below. So our overlap is this region in between those two vertical lines. Just right there. Any questions about these? Have a handout for you, because I don't like